Welcome to qnawire.
Hi, in the given problem, the particle of mass 3m is moving towards right, or we can say it is moving along positive x-axis with a speed vi, and the particle of mass m is moving towards left, or we can say it is moving towards negative x-axis. As the speed is same, so the velocity will be minus vi, as the direction is opposite. Now, when they collide with each other elastically, the object, this particle of mass m, goes down along negative y-axis. Suppose its speed is vmf, the final speed of the particle of mass m. It is represented as vmf. And the another particle of mass 3m, suppose it goes here like this with the speed v3mf. The final speed of the particle of mass 3m, it is represented as v3mf. Suppose it is making an angle of theta with the positive x-axis. Then the component of its velocity will be along positive x-axis. This is v3mf cos theta, and along positive y-axis this is v3mf sine theta. Now, as it is a perfectly elastic collision, so first of all, we will use the momentum conservation along x-axis. So, using conservation of linear momentum along x-axis, so the momentum of this particle of mass 3m, that is 3m into vi, plus the momentum of this particle of mass m is m into minus vi, and is equal to the final momentum. So finally, as particle of mass m is moving purely along y-axis only, so it will not be having any momentum, any linear momentum along x-axis. So linear momentum along x-axis is only that of the particle of mass 3m, and that is given as 3m into v, 3mf cos theta. So here this is in left hand side, this is 3m into vi minus m vi is equal to 3m into v, 3mf into cos theta, or we can say this is 2mvi is equal to 3mv, 3mf cos theta. Now we can cancel this mass here. So it becomes twice of vi is equal to 3v, 3mf into cos theta, or vi is equal to 3 by 2 v3mf into cos theta. Now we will use the conservation of linear momentum along y-axis. Now, as both the particles were initially moving only along x-axis, so there was no initial momentum along x-axis, so this was 0. And finally, here this is 3m into v3mf sine theta along positive y-axis, and plus m minus vmf along negative y-axis. So this m vmf becomes equal to 3m v3mf sine theta. Cancelling this m again, this is vmf is equal to 3 V3 mf into sine theta. Now we will use conservation of kinetic energy as it is perfectly elastic collision. So now using conservation of kinetic energy. So initial kinetic energy of particle of mass 3m is half into 3m into vi square plus that of another particle of mass m, half m into vi square, is equal to the final kinetic energy of first particle, half m into its speed vmf square, plus that of the particle having mass 3m, half 3m into v3mf square. So here in left hand side it comes out to be 4 by 2, or finally it becomes 2 m vi square is equal to half m. For vmf we will use this expression 3 v3mf sine theta. So it becomes half m into 3 v3mf into sine theta to the whole square plus 3 by 2 m v3mf square. Now this mass can be cancelled from both the sides after taking it common in right hand side. So here this is 2 vi square is equal to 9 by 2 v3mf square into sine square theta plus 3 by 2 v3mf square. Now from this expression vi is equal to 3 by 2 v3mf cos theta, we will put this value of vi here. So it becomes twice of the square of vi, means this is 3 by 2 v3mf cos theta to the whole square is equal to 9 by 2 v3mf square sine square theta is equal to 3 by 2 plus 3 by 2 v3mf square. So finally here it comes out to be 9 by 2 v3mf square cos square theta is equal to 9 by 2 v3mf square sine square theta plus 3 by 2 v3mf square. Again here we can cancel this v3mf square from both the sides after taking it as a common from right hand side. So finally we are having, and even we can cancel this 2 in denominator also. So finally it becomes 9 cos square theta in left hand side is equal to 9 sine square theta in right hand side plus 3. So if we rearrange it, this is 9 cos square theta minus sine square theta is equal to 3. So here this becomes cos 2 theta equals to 3 by 9, means 1 by 3, or we can say this is 0.333. So this angle 2 theta will come out to be cos inverse 0.333, which if we calculate it, it comes out to be cos inverse of 0.333 is 70.55 degree. So finally this angle is 70.55 degree divided by 2, or the angle comes out to be 35.3 degree. And this is one of the answer of the given problem. Now we have to find the speeds, the final speeds achieved by the three particles VMF and V3MF. So to find these speeds, first of all, from the relation VI is equal to 3 by 2 V3MF into cos theta, this V3MF comes out to be 2 VI divided by 3 cos theta, means this is 2 VI divided by 3 into cosine of 35.3 degree, or it becomes 2 VI divided by 3 into 0.82, which finally comes out to be V3MF is equal to 0.81 times of Vi. The final speed achieved by the particle of mass 3m in terms of Vi is 0.81 into Vi. And at last, we have to find the value of this VMF, for which we use the relation of sine theta and cos theta, or simply using this VMF from here. This VMF is given by 3 V3MF into sine theta. So this VMF, final speed achieved by the particle of mass m, comes out to be 3 times of V3MF, which is 0.81 into Vi into sine of 35.3 degree. So this is 3 into 0.81 into, for this sine 35.3 degree, this is 0.5774 into Vi. So finally it comes out to be 1.41 times of Vi. So this is the last answer for the given problem. Hence, these two are the speeds achieved by the two particles after the collision, and angle theta is 35.3 degree from the positive x-axis. Thank you.